In this video, we're going to be looking at how to solve absolute value inequalities. Since there's an absolute value expression in here, what we expect to happen is that there is a double boundary. Almost all the time, there are going to be two different points that create the boundary for this inequality. So the first step is to solve it as an equation, which means you take this inequality symbol and you substitute an equal sign in there. And so then you just solve it as you see it, as you would any other equation. So first we're going to subtract 16, and then after that, we have 3 times the absolute value of x minus 2 is equal to 18, so we will divide by 3. And once we do, we have the absolute value of x minus 2 is equal to 6. At this point, that's where we can find our double boundary points, because we're going to set the inside of this, the x minus 2, which is inside the absolute value, equal to either 6 or equal to negative 6, because that would both make the absolute value work. So here we have x minus 2 equal to 6, and x minus 2 equal to negative 6. It's a great way to show your work as to how you're coming up with these boundaries. And so you have x equals 8 and x equals negative 4. Now that we've solved this equation, now we're going to take it back to the inequality part. So we're going to draw a number line and label the boundary points. So here we have our number line, and we're going to make sure to put our boundary points that we just solved on there. As you put those points on the number line, we have to remember to think about open versus closed. So an open circle means that we are not actually equal to that boundary point, but a closed circle would mean that you can actually equal that boundary point value. And that's all based upon your original inequality statement. In this particular case, it's a less than symbol. There is no or equal to, so our boundary points should be labeled with an open circle. So here you can see that these boundary points here, we have negative 4 on our number line and 8 on our number line. Now what we need to do is determine which region it is that actually satisfies this inequality, because there's many x values, infinitely many x values rather, that solve this inequality. So they could be over in this region, which is less than negative 4, could also be in this region, which is above 8, or it could be in the region in between them, and that's what we need to figure out next. So what we do is we test an x value between the boundaries. That's the easiest and quickest thing to do, is to take any point that is in between these boundaries to test it in the original inequality. The x value of 0 is definitely the most simple x value to plug in for you to be able to test. So that's what we're going to do in this example. So now what we do is you plug 0 into x in your original inequality, and you just simplify that inequality. So we have negative 2, absolute value of that is a positive 2, and you multiply 6 plus 16 is 24, and we end up with a statement that says that 24 is less than 34. And in all this process, what we're trying to do is figure out if it's true or not. Definitely 24 is less than 34, so therefore x equals 0 does satisfy this inequality. And what that means is that all of these x values between negative 4 and 8 satisfy that inequality. 0 we just chose because 0 is an easy number to plug in. You could have chosen negative 3 or 4 or any of these x values, but 0 is the easiest to plug in, and it did satisfy the inequality in this example, which means all of these x values do. And so that's why if the test point satisfies the inequality, then you shade in between those boundary points. If it happened to not, then you would shade on both sides of the outside of the boundary points. So as you can see here, what we've done is that we've shaded in between, which represents the fact that all of these x values satisfy this original inequality. The final step is to write the answer as an inequality. So we use this number line to help us. And as we take a look, it'd be negative 4 is less than x, which is less than 8. Our x values that work are between these boundaries, and so the x value in the inequality is also between them. This statement is kind of a two-part statement written into one, where you'd say negative 4 is less than x, so all of our x values are bigger than negative 4, but also all of our x values at the same time are less than a positive 8. Those would be the two ways to show the solutions to your inequality, one being a algebraic inequality statement and one being a graphical number line statement. And an extra note would be that if you happen to have an inequality statement where the shading region would be on the outside of both of these boundary points, then your inequality would be two separate inequality statements. One for this region over here where you'd say x is less than negative 4, and then a second over here where you'd say x is greater than 8. if it happened to be a different inequality, and so we'd have two separate regions. So that's something to keep in mind as you are solving these absolute value inequalities.